Okay, welcome to another episode of the Vehicle Network podcast. And today I'm delighted to be joined with Ben Johnson, who is an experienced fault finder, according to his LinkedIn profile, specialising in BMW. And I've been following Ben for some time on LinkedIn, and he does post some really interesting articles around his work that he does around fault finding. And I know that some of our audience will find this conversation of real benefit with regards to just understanding a little bit more maybe about the BMW brand, but also the implications of faults that are on vehicles. And no doubt Ben will reinforce a lot of people what a lot of people need to be doing in our world of investigation when he's trying to investigate a fault and keep an open mind. So welcome to the Vehicle Network podcast, Ben.
Thanks very much.
I wonder if you could just give us an introduction and just tell us your story as to how you've ended up as an experienced fault finder specialising in BMW. And I appreciate you are over in Finland as well. So a little bit of a journey perhaps to tell the listeners about.
Well, I mean, I started back in I went to college in 94, Pagefield in Wigan.
Yeah.
Ken Morris is unfortunately probably not with us anymore. And I learned a lot from them old lads there. Back in them days, there wasn't much sort of diagnostics with computers and laptops. It was like more mechanical, really.
Yeah.
From there, really, I went for my first job at Rover, Foxfield, which sadly doesn't exist anymore, which is a Rover Fiat dealer. And been in the industry really ever since. Sort of got into diagnostics, I'd say about 2004 at Nissan. When I started with Nissan, I really started to get interested in it because at first, believe it or not, I'm supposed to be quite good these days, people say. Back in 2004, I was only just starting. I wasn't very good at electrical problems, and it annoyed me actually because I couldn't fix them. I couldn't, I would hit a brick wall many a time. So I just started put me head to the grindstone and reading and learning, and a few people helped me along the way. And year by year, I got better and better, and I am where I am today, really. But I'm lucky because I've worked for so many different manufacturers. It's not just BMW. I mean, that's my main sort of thing since I came to Finland in 2013 from England. I started on a small place near the Russian border in Lappeenranta, and I started to do BMW as a little garage there. And then the manager at this big dealership in Finland noticed I was fixing a lot of cars, which were going to their place and going to our little place. And then he said, "Listen, you're fixing. I've heard you're fixing our cars here. What's going on? Do you want a job?" I said, "Yeah, why not?" So I jumped at the chance. Yeah. And then I moved over to the Helsinki area like 2 years ago. And I'm working for Schmiedman now, which is a pretty good place. We can do pretty much everything on BMW there. That's where I'm up to at the moment. I get a lot of stuff from other garages where all sorts of nightmare jobs, like 10 people have looked at it and like they've replaced everything, wires are chewed to bits, and I've got to work out from this jigsaw puzzle what's going on. I get a lot of jobs like that. And some days I get straightforward jobs, so.
Yeah. And I guess that's because of your experience that people recognise that and go to. And I guess perhaps those are the jobs you enjoy because they are the ones that maybe test you or have certainly tested people who've got
tested a lot, yeah. Tested a lot, yeah. Some days I enjoy it, some days because I'm doing it every day, constantly, day in, day out, more than sort of your service and mechanic work. Some days it's hard though, some days I've really got to think like, what's going on with this.
Yeah.
Then you start investigating, then you have to stop the job because you find some bad repair, let's say, then you've got to put that right. Then you've got to carry on with the diagnosis again. Then you end up finding other faults. Then you find faults in other systems. Then you have to ring the customer. Listen, we found this fault in this system. Would you want to carry on with that? How much do you want to spend, really? I mean, with BMW, they're not easy. And you could 10 hours easy on some diagnostic jobs. Some can be 1 hour, but they can just go on and on. If someone has the money and they want to fix it, I can go on for a long time and make it perfect.
And how do you think it's helped you working across different manufacturers?
It's helped me a lot, really. I mean, training-wise, let's take, for example, when I was with Nissan, I used to go to Maple Cross in Watford. It was absolutely unbelievable. Andy Mavrinaitis and John Gardner, two good trainers. They were both really good mechanics in the day. And I learned a lot from them. They were like the old school type of trainers where they didn't just read off a script. They would say to you, look, this is how you need to do it. This is a shortcut. And I learned a lot from them lads. Peugeot was probably one of the best places, I would say, for technical training. I learned a lot about, I would say that was my breakthrough with electrics, because actually Peugeot technical training is quite difficult and it's quite strict actually. Whereas with your Nissan, no problem. You just do a few courses and you're a Master Tech. Peugeot Master Tech is a lot more difficult and they really test you. Yeah. And you've really got to think with that. So yeah, answer to your question, both of them, but mainly Peugeot definitely helped me along the way. And then when I got to Finland, I learned a whole new technique for Finnish guys and gals. And I learned a lot more back then as well. So, I thought I came to Finland in 2013, thought I was an expert, and I didn't know anything really, because these lot here, back when I was in Lappeenranta, I couldn't believe how good they were. The simplicity, they made difficult jobs simple, and I learned a lot how to simplify things.
Yeah.
In that sense.
I think as you learn more about a topic, you do realize that you know less than you think Absolutely. You do. There's sayings around how much you think you know versus what's actually out there, and until you delve into it, and you kind of hit the nail on the head for me that you kind of say nothing, because that's even though I spend a lot of time doing what we're doing, it's like I just feel as though I've only just begun, or I just don't know nothing. And I think the automotive industry, because of the different facets of it, it's just impossible to keep abreast of everything with the time you've got in a day and the stuff that you're exposed to versus what's actually out there, to get across all those things. And all you can do is just keep repeatedly exposing yourself. And what you touched upon before about sometimes day in, day out, you're kind of doing it. But what you don't realize is that those day in, day outs are the day in, day outs that are giving you all that experience that you don't realize until you maybe come to a pause point either in your life where you take a step back from it all, and then you can see how far you've come. With regards to your experience, bro, I think it's great that you've worked for different manufacturers and you've seen different standards of training, perhaps, that then allow you to know where the sort of standards are when you're doing your work now, and it'll give you some clues as to how to resolve those issues. And touching upon perhaps those people that taught you in the earlier days, training back then might be slightly different. And there's people that I know in the automotive industry now, like my dad were in the automotive industry, and some of his colleagues who, are sadly getting older and older, and you want to just get all that experience off them and download it somehow to be able to pass it on to the next generation, because it set them in good stead throughout. So fairly well versed across different manufacturers and different countries as well, which is important because there's a lot of things to be learned from the way that other people do things. And there are more than one ways to skin a cat, as they say. And perhaps when we get out of our own areas and start to speak with other people, we can see those other ways. So I think it's fair to say you've got the experience and the knowledge and variety to be able to perform like you do, and to give us quite an insight today with regards to fault finding and diagnostics, really. And that's where I want to start, if I can, Ben, with regards to that. Can you just talk us through really how you would, what are the sort of things that you would do in initial stage of being presented with a fault, as regards to sort of narrowing down the issues, I guess?
Well, it's a difficult one because every day is different, you see, and I don't have a specific blueprint like A to Z. And that's the trick, really. That's the secret, is that you can't get sort of stuck in that mindset of doing everything the same way. Sometimes you can cut a lot of corners. The first thing I do is I gather evidence, and many people don't do that. If you look at the car, you don't even need to plug a computer in to check the fault code. Sometimes, you can gather the evidence. You can look at the job card. You can look at customer complaint. Then you need to, let's give an example, shall we? Let's try and come up with a basic example. Let's say customer says the car has a lack of power. Well, a couple of weeks ago, one young lad was looking at a job, and just some 20 meters away, some distance, I could hear the exhaust note, and I knew it was a camshaft problem with the exhaust side, and it was a stretch timing chain, so the timing had gone out. So in that sense, based on experience, just by listening to a job that was 20 meters away across the workshop, I could sort of say, check the fault, it'll have a camshaft position sensor fault code, which means the timing's out, and then you have to physically check it. And that's what it was. So that was one example of how I would do something based on experience. But let's take an example of a job that I haven't seen before and it's an unusual fault, then how would I start that? Well, the first thing, obviously, is, as I say, look at evidence, read the customer complaint. Can I get something from that? Can I discern some information? Let's make a note of that. Then I'll plug the fault code reader in ISTA or Autologic, which is the two machines we have. And then I'll look at the faults. And let's say we have like an issue with a CAN bus fault. A typical BMW problem is a body CAN fault, which is K-CAN. What I'll do with that is there might be 50 fault codes, but if you, as you've seen on some of the LinkedIn posts I do, I'll do a 3-stage process. So what I'll do is I'll print the first lot out and I'll erase it and see what comes back. A lot of it is consequential faults, which you'll only get as the vehicle's driving because there's messages which should be on the bus which aren't there. So you'll get additional messages. When you do the second print out, you'll find kind of only the sort of the more critical areas of error. So if you take a K-CAN system, it's body bus. So the easiest place you can start to then look at, okay, let's look at the bus. Let's physically see what the signal is. In rare cases, other than scoping it, I'll take the battery off and I'll measure the resistance of the bus because, you know, they have terminating resistors. But usually I'll just whack the old oscilloscope on in the most easiest location, let's say. And the best place is usually park distance control in the trunk. I'll whack that on and I'll have a look at the fault code. No, the signal. Say the signal's a bit dodgy. I know I've got an issue then. Then I start unplugging units. When the signal comes good, I'll erase the faults. I should only usually be left with the one fault code of the unit that's been unplugged. And that's one way how I will do that. Other people do it a different way, but that's how I would do a CAN fault. Other type of faults, like I said, I'll read the fault code. Then I'll use whatever equipment I've got to do it. Let's say it's a sensor, I can use a fluke meter, I can measure it. Or let's say it's something else, I can use this Power Pro Maestro, what I've been using a lot of to power something up, like the wiper motor I did the other day, you know. So it's very difficult to sort of say what my process is because every day it completely changes.
Yeah.
And that's the knowledge you see. Like when you get to that point, you know exactly what's the appropriate method to use. Then what tools do we use? And basically, at the end of the day, we just want to get the job done as quick as possible, but done right. So it's pretty hard to give you a specific answer, really. I don't have a specific method. It changes constantly.
It's a really good answer, if you don't mind me saying, Ben, because sometimes in our world we're pigeonholed to do stuff in a forensic manner, which has got to follow what we call a set procedure, a quality management system. I'm sure the same for you. If you're going to replace a part, then there's going to be a process to go through. But often, because of the variety in the automotive industry and the different types of vehicles that you see, the different models, the different platforms. They're going to throw up, different solutions and different ways, and following that A to D or A to H process is not always going to give you the result you want on your vehicle, and especially with yourselves who are, perhaps wanting to get the job done, as quickly as possible, which is for everybody's benefits from, both the dealership's point of view and to keep the customer satisfied. You do need to make those shortcuts, shall we say, but I think you can only make those shortcuts when you've got the experience to be able to miss a couple of those steps out sometimes. So I think it's a really valid point, and it's something that certainly challenges us sometimes when perhaps we should be doing something in a certain way, but we know it's just going to take us either nowhere or we're doing it for no benefit other than ticking boxes to a degree, which is all right in the main, but when you get into bespoke stuff, you can't be doing that some of the times because you're either losing time or you're kind of messing things up a little bit. And I guess some of the differences that you touch upon there from what we would do is, we shouldn't be changing data on a system, and you have to change data on a vehicle to eliminate what might be wrong, as you touch upon there, by disconnecting various components to then be left hopefully with an isolated fault or issue that can resolve your particular fault on that vehicle. You mentioned a couple of tools there that you'd use, Autologic and ISTA. If you just wouldn't mind explaining what those two are for the benefits of our listeners.
Well, yeah, obviously ISTA is the basic BMW dealer standard tool. which you can do basic fault finding and programming on that, of course. So you can update systems. If you replace a unit, you can obviously program and code them. But being a non-BMW dealer, we use a standalone system, which is EOS. It's like a non-dealer version of ISTA. So unfortunately, we don't have local files, so we can't really do any sort of in-depth searching of log files and stuff like that. But it's pretty good. €360 a month. It's not cheap, but you can do everything, service, resets and stuff. Autologic is totally different. Obviously, it's a British company.
Yeah.
It's a good tool. It's a little bit, we've got the slightly older version. It's not the fastest, but it's pretty reliable. And if you want to pay €2,500 a year, you can get the programming support what you need as well, which on older cars is faster than ISTA P, which is the old programming version. So for E90s, E60s and stuff like that, your old 5 and 3 series, you use ISTA P, which isn't the best. There's not much support for that now when it runs on Internet Explorer. So we use generally Autologic for that. Yeah, because it's just basically more reliable and it's quicker in that sense. Autologic too has a few more benefits, but there is a few issues with Autologic. Sometimes the data isn't really perfect. Sometimes it gives slightly erroneous data. It doesn't quite match up with ISTA. But, you know, it kind of does the job. And if you're on a road test, it's a lot handier than having a laptop with Ethernet cable. Again, we can't do that with ISTA because we're not a dealer. So our local version only works on Wi-Fi in the workshop. So we can't use that locally. So that's also why we use Autologic to pop down the road and do some, you know, with a co-driver so you can monitor the data for safety. That's what we do with those,
Yeah. And there's a couple of points you highlight there that's really kind of relevant for us, and that's the fact that the expense when you're looking at maintaining a tool that's going to, you know, keep up to date with the changes that go on, and B, requiring more than one tool is often because one will be good in one situation and another will be good in another, and you start to multiply that by different brands, and you're into a lot of money to maintain, you know, a tool portfolio or a software portfolio for, you know, interrogating vehicle systems for just faults, you know, if it's just a diagnostic tool, not to mention some of the other tools we've got to buy for other data acquisitions that we do. So it's, you know, it's quite an expensive hobby, keeping up with diagnostic tools, but it's interesting to hear you hear you mention the fact that you will use more than one. And the other thing, of course, which is relevant, is needing that internet connection as well to do a lot of work these days. And, you know, we're seeing a few things being locked down on various ECUs and getting access through that diagnostics port for automotive cybersecurity regulations that are coming in, and the, you know, manufacturers having to make things a little bit more difficult for things to be accessed to stop, you know, car hacking going on remotely, which is, you know, starting to become prevalent, and it's going to be a real challenging area, I think, for people like ourselves, but also, you know, people like yourselves as well, that are sometimes limited as to what you can do, and they're just going to give you the sufficient to do what you think they need you to be able to do, and it's not necessarily always the case in regards to that. The other thing I wanted to ask you about was, just because a diagnostic system gives you a particular fault, would I be right in saying that that's not necessarily going to give you the answer that you're looking for, and it's just a clue in some scenarios to point you in the right direction?
Yeah, and that's actually the biggest misconception, isn't it? With customers always say, "Oh, you've got a fault code, you must know what it is." No, let's look at a system that's like a network-based system on a bus system. Like if you've got one missing sort of set of messages from one component because let's say it's dead or the power supply is gone, you'll then have 30, 40, 50 more fault codes, and they all basically rely on that component. They want to see a message, but it ain't there, you know. So not really. And like I said, you've got to be able to understand what's the main sort of, let's say, control unit that's causing the fault, and then you can work out from there. Because let's be honest, 50 or so fault codes is typical on a BMW with issues, and you can disregard about 45 of them, really. And that's the trick, is to understand what it means. And actually, they're very good systems, because if you think about it, the reporting control unit will always tell you the unit that it wants to see the message, which it can't get. So let's say you've got a steering system what's failed. Well, you might have the brake DSC system saying missing message from steering rack. And then engine ECU might also say missing message, steering rack, transmitter, steering rack, receiver, engine ECU. And then when you see the receiver and it's saying, I need this message, but I can't see it, then you can easily narrow down the unit. And actually, most of the times, that's how easy it is. It's not difficult. You just need to understand what's going on, really. And most of the time, it's down to either a failed unit or power supply. But yeah, the fault codes, really, they're not so easy. When you start getting into Ethernet and FlexRay and stuff like that, you need to then start understanding how to troubleshoot it. So it gives you, as you said, a very small sort of snapshot of the area you need to look at. But by no means, it's definitely not, oh, there's a fault code, this is the fault. Like 10 minutes later, let's fix the problem. It could be hours, you know. So no, it doesn't work. Sorry.
And just because fault codes are present doesn't necessarily mean there's a fault with a particular unit. It might be the fact that it's just not seeing the message that it's expecting.
Yeah, that does that as well. And then you could also look at it like there could be a sensor which is an input to that unit, but then also that unit should input a message on the CAN bus or FlexRay, because other systems need that information also, and then it can't provide that information because a sensor's failed. So then you have to start looking at what sensors failed. It's not necessarily a control unit was broken. It's just doing its job. It's reporting it, which without it, we'd be in trouble, wouldn't we? We wouldn't be able to understand what was going on, you know?
Yeah. So it's been interesting to listen to, obviously, the way that you, go about fault finding and looking for those particular possible faults based on experience, then plugging in some diagnostics equipment and having a look at that to see what's going on there. What I wanted to talk a little bit about was, how may these faults start affecting some of the other units that, say, me as a forensic vehicle investigator is looking at, say, an infotainment unit as one example. If I don't take account of, say, faults that might be occurring elsewhere on the vehicle that could be affecting that unit. So if I just look at that unit in isolation, could I be missing some vital information by not taking account of some of those other units?
Yeah, you could. I mean, give you an example, a really weird one that happened to me a few years ago. If you're talking about telematic control units, I had a BMW E90. Funnily enough, when I went for a job interview, actually, at a BMW dealership in Finland, they had this car in, and I pretty much told them what it was, although I was slightly wrong. And yes, that unit wasn't communicating on the fiber optic MOST bus, media orientated system transport bus. And if you put a MOST loop on that, you can bypass it. But then you need to look, as you said, other systems. So the problem with that job, which was really weird, from the factory, don't ask me how this is possible, but there was no terminal 15 power supply to the unit. So it had never worked from day one. From the factory, it was really weird. The power supply from the junction box, electronics, there just was no wire there. And this unit was dead from day one. And I don't know why. It came from France originally through Estonia, so maybe they changed the wiring on this, who knows. But really, it did look factory, and it looked to me like it had never worked from day one. And that was a unit that was several €100, but it was dependent on having power. Well, there was no power, so I ran it from a spare fuse, and it worked immediately, and there was no issues. But then having when I did power the unit up, then I started having other issues on K-CAN, so that became a massive job. But it's just one example of, if you get tied down to something, always check you've got power, ground, and make sure everything is as it should be, because the result of that unit was every now and then the central information screen would chop off. Right. It was really, really an unusual fault. And it goes with anything, really. I mean, units might fail, but there's reasons for it. It's generally more simple things like wiring or things like that, you know. But that was the weirdest thing I've ever come across in my life. I mean, I didn't expect, I wanted to check the power, but there was actually no physical wiring receptacle, which was weird. So we were all set to change that unit until I checked the wires. There's only a few wires on the power side. Yeah, that was weird. So definitely you should do that. Yeah, you should check everything before you change things. Things dependent on things.
It's another good example, I guess, of why you do need to check these things, because as far as you're concerned in that case, it's potentially being like that from the factory. And it's weird, these things this shouldn't happen. Again, they're going through a quality management procedure. But whether or not it was the factory or not, irrespective of that, we've still instances where people will meddle with their own cars, or other people have a go at them. And when you're going into it, for me, you need to try and at least scratch under the surface to make sure everything's all right, either whether it be through a scan or some physical checks that, things are in there. Do the majority of BMWs with an infotainment system have a separate telematics control unit, or are they integrated into the same module?
No, they're all different now. They used to be called Combox years ago, and they were all separate units. And even now, they're kind of separate units as well. Nowadays, so let's take G30 5 Series. Not that they're quite old now, aren't they, if you think about it? But they're in a real bad place. They're in the roof. So now part of the service on them, when you do a service, is if you have a fault code for telematics unit battery low, you have to change that battery. It's behind the roof line at the back. It's difficult. No, it's kind of difficult. You've got to drop it down. But they've moved it from like being a huge unit. It was like a massive thing like this in the trunk. And now it's a lot smaller and it's in the roof. And it's like SDARS. It's a bit like on sort of aircraft, but it's called SDARS on cars these days.
Yeah.
But it's a bit of a stupid system because the old ones were a lot easier to get to, and now these are a bit of a nightmare. They're in the roof, and you've got to whip the old lithium-ion battery out every now and then and change them. But they're sort of standalone units, really. Yeah.
And do you find that you get many faults on like telematics units? Or...
Water, really. In the roof-mounted one now, basically water, corrosion. Biggest problem on BMWs, and they're very good cars, but it's always like in a finished climate, it's so harsh. You just tend to get things like corrosion on the pins. Like I had a CAFAS camera the other morning on an i3 with corrosion. It's the same thing. But other than that, no, there's not really many issues. The only issue usually is BMW's back-end system. Sometimes they're updating or crashing, and the customer might get a few sort of check control messages that like such and such is not available, but that's beyond our control, really. But no, it's generally very good. No, to be honest, they're pretty good cars. They're pretty reliable in that sense. So
no, it's a valid point that you make, and one that I would reinforce around vehicles. They are designed to go everywhere in the world just about, and they're exposed to the elements. So we're asking all these small electronic components to operate in temperatures between -20 or even more, all the way up to 40-50 degrees, and things are going to start to affect them in a lot different ways than maybe a normal electronic device, such as a phone or a computer sometimes, because of the elements that they are exposed to constantly. Even if you left your phone out overnight, then potentially it's going to start deteriorating somewhat and not performing as it should do. And these sorts of components are sometimes at the extremities of the vehicle, like you identify in, body paneling or in the roof paneling, that are getting those exposures. So it's interesting to hear that they do, but in the main, from your experience, tend to be all right. But it's still worthy of a check. And perhaps it's not that easy to do a physical check on that type of unit that's in a roof for somebody that's just maybe got an hour or something like that to look at a vehicle and recover something for it. And I guess it sort of links into why diagnostics sometimes can just give you a little bit of a heads up as to whether or not there is an issue. I mean, from our side of things, when we're investigating, say, serious crime, we'll get people that maybe steal these vehicles and then try and disable those components so that they're not tracked, or they're not going to alert the e-call facility, perhaps if in the event that they crash vehicles. So sometimes that can be as crude as panels being ripped off when you can see that it's been dismantled or crudely cut out. But equally, sometimes it can be done quite to a high standard, whereby unless you're really going to scratch under the surface, you're not going to find it. Can you talk us through a little bit about the BMW network architecture around, the different sort of networks that are on there? You've already mentioned CAN, K-Line, most, and do know from some of the latest crash data that's being given up by BMW, when we go direct to module, then we know that some of them are on FlexRay as well. Don't know where you want to start with
FlexRay is a good one.
Full network topology, but
no, it's fine.
Are we covering? There are a lot of those networks on those systems, and perhaps what ECUs are running on what systems that people need to be sort of mindful of, because sometimes we can get a bit pigeonholed to CAN and just CAN alone.
Yeah, CAN's a bit old now. I mean, CAN's done its job for years and it's still useful, but it's, it only has a fixed bandwidth. It can't cope with too many. The modern units now on these cars, there's that many. It's not possible really for CAN to process everything. It's going to get congested really. So that's what FlexRay is for. FlexRay was an initiative that came about because it has to be safety critical, but it has to be absolutely spot on fast. It's actually 10 times faster than CAN is FlexRay.
Yeah.
So,
and what sort of systems would you have on a FlexRay in a BMW?
Suspension, DSC with brake unit, basically all powertrain components where safety critical and timely information is required. So CAN just doesn't cut the mustard really because it's not fast enough. The baud rate isn't fast enough really. That's the only reason FlexRay was invented.
Yeah.
Prior to FlexRay, we had Byte Flight, which is fiber optic. It's a little bit like most, but a bit different in that sense. There's 3 generations of that. And that's also, again, generally on the older BMWs, it came out, I think, 2001 on the 7 Series. It's more for a safety, like airbag circuits and stuff like that. And that's a star configuration. And that's very old now. And as you can see, we don't really use that anymore.
No.
Nowadays, it's basically Byte Flight and Ethernet. Ethernet's the fastest, of course.
Yeah.
And I think everything will probably go down that route eventually. But at the moment, yeah, it's FlexRay is probably the fastest at the moment in terms of BMW. But they're changing all the time. There'll be something even newer soon. So they're trying to bring out an even faster CAN protocol at the moment. But there's LIN bus for single wire bus. We have that, which is generally low cost. And it can control things for example, door motors and window lifters and things like that. Even the alternator, oil sensors, battery negative terminal sensor, which can check the battery current draw. We had in the past bit serial data BSD bus, which is single wire. It's a little bit like LIN, but it wasn't very reliable and it's very easy to destroy the controller. So they've kind of done away with that and gone back to LIN.
Yeah.
But it's the same sort of principle, a square wave signal. What else have we got? Scent. That's another type of thing. So if you look at AdBlue, AdBlue system, the level sensor, which is generally ultrasonic,
right?
Which is great until it freezes in Finland. It doesn't work at all. Then that signal is called a scent signal, and that's sent in what's called nibbles, and it's something that which is. We don't have the scope in this discussion to describe how it works, but it's just yet another sort of protocol that you need to understand how it works, because you can scope that, you see, you can look at an oscilloscope, but you must understand how it works. So that, and it's a good point actually, because if we look at, like, say, another manufacturer, like say something Japanese like a Nissan, you don't have all these networks. So it's kind of a lot more simple really, but on BMW, not only do you need to understand what network you're dealing with, but you need to understand when you see a scope pattern, what sort of voltages. For example, on FlexRay, it has a pull-up and it has a pull-down voltage. So it's not like CAN at all. It doesn't have terminating resistors. It has resistors on each node, if you like. Yeah. So it's troubleshooting that is not easy. And CAN is easy. CAN's beautiful. I love CAN. It's the easiest way to troubleshoot. I mean, it's not rocket science.
No.
But it's complicated, and it's going to get more complicated, I think, pretty soon.
It is, and it's sort of why I asked that question, really, just to at least open up people's minds to the fact that it's not just CAN, and there's so many different systems on a vehicle that are operating and interfacing with one another. That it's very, very complex with regards to to how it's operating, and you could just specialize in one network, I guess, to a degree. And sort of really get into a rabbit hole of, specialisms with regards to the architecture on a vehicle. And then, of course, like you said, the new technologies that are coming out, how do you keep up with it all? It's a very challenging arena, I think, to be working in, and certainly one that you're working in when you're trying to fault find and work out what's wrong. I wanted to get your opinion on, or your view on, repair versus new parts, because there's a lot of talk at the moment around, being eco-friendly and trying to, reuse certain things. And I'm sure you perhaps would advocate that as a little bit, dare I say, old school from perhaps in times gone by when we didn't. But over the last 20 years, a lot of parts for consumer products, just no repairs go on, in the sense that we're just told to buy a new kettle, we're told to buy a new dishwasher or a new washer. Do you think that's going to go the same way with vehicles, in the sense that they don't want you to repair these parts because of the safety aspect of things? Or what's your take on that, Ben?
Well, I mean, any manufacturer is going to want you to change it. No dealership will repair parts. It just doesn't happen. I mean, first of all, like you said, safety part of it. And then if you look at the parts you have to return, a lot of the time, they want to check those parts, because let's say BMW, they might want to look at the quality and, you know, what's gone wrong and countermeasure it. So in that sense, you'll never fix it. You'll send it back. Outside of warranty, of course, and for an independent like Schmiedman, where I work, then obviously, if you can fix it, you can fix it. But there's fixing and there's fixing. I mean, you can't sort of try and fix, let's say, an hydraulic pipe that's got an hole in it, because we don't have the equipment for that. But when it comes to like that amplifier I did not long back, a few weeks ago, the whole system was going blank and the screen was going off. That was just something I was interested in, purely and simply because the guy had the money and he could pay for a new one, no problem. But let's open it up and see what the actual problem is, because at the end of the day, it's knowledge, and then we know what's wrong with the next one. Then we can maybe just buy a new one if we need to. But that was something that, give it a go. It takes half an hour to strip it, and if it works, it works. And it did. It ended up working, and apparently it's still working. If it fails, we change the unit. But, you know, some customers don't have the money. If they can pay 2 hours to try and fix it, on the understanding that, listen, you know, if it fails, we can't do anything else. We've tried. You pay your money and you get a new unit. But I would prefer to change units. I mean, it's interesting repairing stuff. It's great. You get the knowledge, but it's so much easier. Your day just flows like, this is faulty. The electrical side of it's okay. Recommend a new unit. For me personally, I'd rather do that. Yeah, I do like finding faults, but I'm busy, so I need to get things in and get them out for the next one. So.
Yeah. No, I think it's you know, interesting times with regards to where we are with manufacturing and parts and things like that. And I think, you know, a lot of parts will get replaced, but and you touched upon it there, some customers just don't have the money to do that. And they might go around 2 or 3 other dealers that, you know, or operatives, shall we say, that might repair it, or spend the time on trying to repair something versus repairing that part. And then one of those cars comes into our investigations that might have been involved in a collision or something, and the repair's not done, you know, to that standard. With all those issues around, you know, the repairs of vehicles with ADAS systems on and the recalibration, and you put that through a main dealer versus asking somebody to do it who's not got the right proper equipment or had the right training. But people will, because, you know, there's a lot of financial pressure on a lot of people these days, and these sorts of things, you know, can go wrong quite easily on a vehicle, and people will always look to the least line of resistance on a financial front, in some cases, over safety, even though they know that it should, but it doesn't. And then it's, how do we detect that when those vehicles come through our hands in either an investigation from our side of things, or when you know, you're fault finding as well, or if something's under warranty and it's been, you know, bodged to a degree. How do you know, and where does the manufacturer stand on that? So it's a really area that I think we need to be acutely aware of with regards to that. One of the areas that we can go to on BMW vehicles is one of the main gateways. Correct me on what I'm going to say here, but is it the ZGW unit that might be responsible for assisting communication between various different networks and logging information that passes through it?
Yeah, that's correct. Yeah, so it's just like it's in German. So it'd be like Central Gateway Module, or ZGM, ZGW. They have, basically it's the same sort of thing. It's sort of ZGM/ZGW, and basically it's just literally a protocol that allows all the other network types, which are nothing like the same, to talk to each other through the gateway module. So you could even have the body can, gear can, talking to the powertrain can, even though it's not the same protocol and the voltages are different. And that's basically all it is. It's literally a meeting point, if you like, a virtual meeting point for every network that can then, the whole car can seamlessly work together, really. And you need that, because without that, nothing's going to work. Obviously, it needs to decode information and then present. Let's say it can take a body signal, decode it, and it can sort of make that available to the powertrain can in that format. And that's basically the only reason we have that system.
Right. So it's facilitating the communication between the different networks and
that's
decoding
basically what it is. Yes, everything comes from there. That's the heart of the car, or the brain, if you want to call it.
Yeah. Because that module itself is recording some of the faults that are going on the vehicle, and then somewhere in the background of Vista, it is potentially recording the speeds of the vehicle at the time that those faults occurred in what we would freeze frame data. So I don't know whether you see that in some of the other diagnostic tools you use. If you say got a fault on an engine ECU, would you necessarily see freeze frame data in the shape of vehicle speed?
Yeah, you do see that, but it's very basic. Sometimes it's corrupted too. Sometimes it gives the wrong kilometer reading. For what, I don't really know the reason for that. Sometimes it might show 500,000 kilometers and car's done 30,000. So sometimes that generally can happen when there's been, like, say, a momentary lack of communication. It just gives a default value. But yeah, we do see things like, say you've got like some fault code for EGR valve or something like that. You can look into and look at the freeze frame. What was the coolant temperature? What was the engine speed? What was the ambient temperature outside and stuff like that? Other than that, I've been looking into probably getting a decent data logger, really, to be honest, because one thing I'm lacking is good data. And if I can see that, if it's a really hard to spot fault that happens every now and then, I need a data logger. So I'm probably going to go on them soon, really, because with this, it's very basic. And as you said, there is log files, but we can't access them because we have the AOS version. So everything's like sort of stored in Germany. We just have like an app to launch the system, really. So, but very basic data. And to be honest with you, sometimes it's useful, sometimes it's not. But it's not really comprehensive enough to form a diagnostic opinion on, in my experience.
No. I think from our side of things, it's just interesting if we get cars involved in collisions that have captured some freeze frame data, then it might be an indication of the speed of the vehicle. And if we can access those through a shall we say normal diagnostics tool that might give us it, versus some of the work that we would have to do to get this information that's been recorded by the gateway module in the background of Vista, is not exactly straightforward and is apparent to you when you use the ISTA diagnostic tool. It's not in the software there. You've got to start heading into some of the files behind it. I think it's just useful to know that freeze frame data still does exist on some of the ECUs with some of the standard tools that you would, a good diagnostic tool might give you that some of that information, and we're using it in a completely different way to how you would be using it from a diagnostics point of view of trying to understand, where the fault is or what's wrong with the vehicle. So you mentioned data logger there. Just for the benefit of the listeners, how would you use a data logger and what's that doing?
Well, I mean, I've not used one at this moment in time, but I've researched it. And the one I was looking at is a Danish one, which, let's say, we can put it in the OBD port. I can set up an Amazon web server. And actually, when I drive in the workshop, it can automatically upload information for me. But that one with, say, Grafana interface, which is a graphical interface, you can look at anything. For example, you could even, it's almost a bit like sort of the tools you might use. So I could use GPS data to see the speed of the vehicle, and I can actually see the yaw rate of the vehicle, the G of the how much G force was exerted. Let's say round a roundabout on a road, we can see exactly how fast someone was cornering at that point in time through all of the data, through the yaw sensor on the car, and then all the other type of sensors, which normally you wouldn't see that. But of course, if you've got a data log, you can see it and you can graph that, then you can plot it. So if someone, like in your field, if someone kills someone and says they weren't doing 80 kilometers an hour round a roundabout sideways and then running into someone on a pavement, well, this sort of data logger would actually prove that, because it would show, obviously, the actual sort of attitude of the vehicle at that time. So that's what I wanted to get a data logger for. But mainly, if we have these really difficult faults that only occur sort of sporadically, I could just leave it in the car for 24 hours, get the customer drive it, then we could download the data and we can actually plot a graph then, can't we? So let's say we have like some component that's failing, and then we could probably see a normal graph, then we might see an anomaly, and then we can narrow it down. Then you see, then it's just a case of, if there was no fault code, let's say, okay, there's no fault code, but that doesn't look so good. Let's check that out. So that's really what I want, because at the moment I only really have sort of basic stuff like any other garage would have, really.
Yeah.
And we need to get more like in depth, really.
Yeah.
Because it's not always straightforward. When you have them sporadic faults, like, there's no fault code. And it's like, I go round a roundabout every Thursday morning at 10 o'clock and the engine cuts out and starts up again. How are you going to find that? Data log is the only way, isn't it, really? But that's the sort of thing you get, you know what I mean?
Yeah, it takes me back to, it reminds me of my dad, because he were in the motor trade and he were responsible for sort of fault finding for customers, and he'd get their cars back and they'd be saying there's a rattle or there's something happening here, and he'd have to drive it for 2 or 3 weeks, and eventually you'd get the moment when it did it, and capture it, and then have to sort of work it out from there. And I guess the data logger is a good solution to just capture everything that's going on whilst the vehicle's in operation, and then hopefully when it does happen, you've got something there that then should be relatively easy to identify, or at least give you a nudge in the right direction to a degree. Okay, one other bit just before we sort of wrap this up with our questions that we normally finish off with is speed data is of interest to us as crash investigators. Wheel speed sensors and ABS units, are they generally reliable, or are we, do we need to be looking for physical examination of these sensors as well when we're looking at data that maybe somebody else has given us from the vehicle? Would it be good practice, do you think, to check those, or, in your experience, what sort of issues do you find with wheel speed sensors or ABS units?
Well, I mean, generally they're quite reasonable. Sort of like your mid-2000s BMWs, there's lots of issues with hardware failing in them, like you have the pumps can fail and stuff like that. And other day I had one with, it won't recognize the going away from that slightly, the pad warning sensor, but it's an internal fault in the unit. Sometimes old Volvos, for example, I'm showing my age now, they would have issues where the old analog sensors would fail, but it wasn't them, it was the unit, just resoldered the joints and then once. No, nowadays, the sensors, so-called sort of active sensors, so they have their own little computer within the sensor, actually. They have their own brain, if you like. Yeah. So they can actually tell if the car is going forwards or backwards, or, and they're designed so that they can be more precise at a lower speed, so they instantly start working. You don't have to wait for the car to start rolling. They'll just pulse constantly.
Yeah.
And they'll just send feedback constantly. But they're generally very reliable. I had one last week on an X1 2018, so quite new, 5-year-old. And it was the left sensor power supply was faulty randomly, again, and one of them weird ones that wouldn't happen very often. It happened to have 2 faults. The sensor itself was faulty because there's something wrong with the evaluation electronics, but actually it was the power supply making and breaking constantly that had made the sensor fail. So the second fault was the power supply. Now, bear in mind, it's rear left, but it was actually the rear right where the break in the wire was, which is weird. I did a LinkedIn post. Yeah, I did a LinkedIn post on that one. It was made very badly at the factory with very little protection against grit and salt. So the wiring is just rubbing together, and it had just been, unfortunately, just sort of broke inside, and it was all green. So that was a good example of that. And generally, sensors are excellent these days. And the only other issue is sort of older cars, say mid-2000s again, is the separate rings, they can swell, and then the air gap changes. So then, of course, you've not got any signal at all because you need a specific air gap on the Hall sensors. Yeah. No, but other than that, they're generally very good. Magnetic bearings can fail after a few 100,000 kilometers. But the biggest thing in this industry is people changing them. Oh, let's just put a sensor on. But usually it's a wiring fault. And DSC unit sometimes. But no, the good sensors are good nowadays. I even made a tool, you can probably see it on LinkedIn, to diagnose those sensors, because they're very difficult to diagnose, really, because you need to use a current clamp, but it has to be very, very small because the signal is so tiny. You need a current clamp that can go into thousands of milliamps range just to pick the signal up.
Really?
So, really. So you can't use a voltage meter or a scope on a voltage setting. So
No.
it's really difficult to get those type of pickups. You need a Pico really, and they're very expensive. So I made my own tool, funnily enough, from an old smoke machine, but that's another story we'll go into another day. Yeah. And actually the case was a Worth refractometer, what you look at sort of coolant with, but that was just like the hardware case. But no, it was very simple to make, a pull-up resistor simulating the DSC module, and then you can get a pulse then back and forth. And you'll see that on my LinkedIn. I made a video about that. No, but no, they're very good. DSC systems, it's always usually a corroded wire. It's 90% is corroded wires with salt.
Yeah. And we would see that via either the owner making comments over speedo's not working, or you would see stuff in, in a scan potentially of some faults that are prevalent because of that. But it's sort of another checklist that you highlight there that, 2018 X1, it's still potentially prevalent that we have to check in case somebody throws it up as a, well, did you check it sort of scenario in our A to Z of some of the checklists that we have to comply with. Tell me a little bit about your All Mech newsletter, because that seems to be getting some good traction lately.
No, well, yeah, it is, and it kind of. I've only got like 61 members, which is a bit disappointing because I sent a lot of invitations out. It's the newsletter itself is good. The group there's like the 61 sort of members, but I think there's 856 subscribers to the newsletter itself. The group is a bit slower, but no, it's good. It's just a way of kind of sharing some tips, if you like. And I think I've got a few more interesting ones up my sleeve that might be even a bit longer than these 3 introduction ones I've created. And I think I'm quite passionate, really, Noel, about bringing everybody together and sharing it, knowledge and getting knowledge of other people, really. It's, I don't like the type of attitude of when you get them people like Master Techs and stuff, like they want to keep everything to themselves because they're sort of worried, like, if I share it, will I have a job and all that? Well, these days it's so complicated that it's better if everyone is at the same level. And unfortunately, like even where I work, I've seen people aren't at the right level yet, and they just need, I think, a little push, a little helping hand to sort of explain things in layman's terms. Even for mechanics, we all need layman's terms sometimes. And let's get the learning going. Let's get everybody at that level. And that's why I created it. And I should have 1,000 subscribers by next month, I hope. And we need to look at, can we do something else with that maybe? Can I merchandise it, or can I spread that into a website and do something else with it? But I mean, let's see what happens with it. I mean, I've had some good feedback, a lot of emails about it. And I think it's going quite well.
Because the number of people I've spoken to on this podcast and, generally in the automotive arena, whether it be us doing vehicle system forensics, whether it be you guys on diagnostics, whether it be automotive cybersecurity, the common thing that's said is that we need to work together. And I don't think there's space for people to be keeping stuff to themselves to a degree. When you've got a community of people, there's enough to go around, if you know what I mean,
absolutely,
to turn it into a much positive traction engine that will drive things forward a lot quicker than it will if people are disjointed and fragmented within the communities that that they're working in. So I really do think that that's a great thing that you've got going there, and we'll certainly spread the word, and hopefully through this podcast as well, people will go check that out if they want to learn a little bit more about fault finding and some of the examples of your work that you do. And what you've got going on LinkedIn is great, because you're constantly on there, and I often wonder how you've got time to post all that really. as well as do the work as well.
I know.
You seem very busy. So let's wrap up this podcast, because I know you have sort of stuck behind to do this, and you're a couple of hours ahead of us. So I'm grateful for it in any way.
No worries.
So as we do, we finish off with these questions. What do you wish you knew before you started in your industry? Your hindsight could be the listener's foresight.
Especially to young people, I always say, don't do this job. It's too stressful. I wish I'd have known the salary weren't so great. No, they're not so bad in Finland, but back home they were terrible. And the stress and how much knowledge, that's basically how much knowledge you need to know, and how fast it's changing, and how you have to keep up with it in your own time, really. If you don't do it in your own time, you're going to get left behind. So, to sum up, salary's not that great in theory. It's getting better. And the amount you need to know, really, we should should be paid a lot more. So I wish I'd have known about that.
Yeah.
The salary, mainly.
Now that we've already probably spoken about this, but is there anything else you'd want to say about a time that you failed and how did you overcome it? But I mean, you're failing every day, aren't you? Yeah. So I think pretty much as a fault finding expert, it's just a common thing that's repeated every day, unless you've a specific you want to put in there.
Oh no, I don't mind admitting my mistakes. I'll tell you. I mean, I've made some daft ones. But I mean, not so much nowadays. When I was younger, God, I did. But no, a few years back in Finland, I was I was doing these ISO-fix bracket modifications on the X3, which is a warranty thing. When I worked for a BMW dealership. And I had all the fire precautions in the car. I took all the back seat bench out. I put fireproof blankets in and everything. And I was welding away, and I'm checking, I'm stopping, I'm making sure I've got my fire extinguisher handy just in case. And I thought, what's going on here? My leg's a bit hot. What's the situation like? Anyway, I lifted fireproof blanket up, and there was a big fire started on the wiring harness of this X3. All the trim was on fire. So I grabbed my fire extinguisher and I put it out pretty quick. And the moral of that story is, even though I taped it down with duct tape, this fireproof blanket, a spark had just popped under it and set the whole loom on fire. Well, how did I succeed that? How did I get over that failure? Well, I basically chopped the wiring harness and spent about half a day fixing the wiring harness. And guy saw the funny side of it, thank God. I had to order some new trim, but I spent a long time fixing the harness. Was this thick, and it was a freak accident, really. But no, I was a bit annoyed. I swore a bit, I think, but I got my head together, had a cup of coffee, and then cracked on. And within half a day, we're done. Yeah, so that was one of my funnier episodes.
Thanks for sharing that with us. If you're not failing, you're not learning, as far as I'm concerned. And even though that's chances of it happening were very small, it proves it can still happen.
Keep a fire extinguisher handy.
Shall we? Well, I don't want to preempt an answer to this, but tell me one recommended resource you could point listeners to. I want to say the All Mech newsletter, but have you any other little gems that people might be able to find out that could assist them?
Well, there's a couple, really. I mean, everyone should read Tom Denton's books. Let's be honest. I mean, Tom's a friend of mine, and I don't know if you know Tom Denton. He's very. He's a font of knowledge, really, Tom, and he's a gentleman. So if you haven't got Tom's books, I suggest you buy them. Very reasonable cost. You'll learn a lot about everything in that. And then if you want to look at specific things about BMW, there's a company in Europe. It might be Czech Republic, I think. It's called Bimmer Profs, and it's very, very good. They're very, very talented people, and they design a simulator for the NOx sensor, which is very problematic on BMWs. But they also have many, many topics on there which describes in great detail of particularly Siemens MSD control units, how they fail and what the common failure items are and stuff like that. So I would recommend, if you're really serious about getting like down and dirty with control units, to give that a read, because they could save you a lot of hassle and they give you a lot of answers on there. So Bimmer Profs, definitely.
We'll have a link to that below this podcast. So that people can quickly get to it. It's a useful resource. Are there any myths about your industry that you wish to debug?
Well, I mean, it's the same nowadays. I think it's a bit better, but everyone thinks we're all grease balls and, oil and filter grease balls. But that's, it's not been like that for 25 to 30 years. It's certainly not like that anymore. And it's with the electric cars and the hydrogen stuff coming online now, you really need to kind of be like a university graduate, really. You need to have that mindset. Yeah. You're always going to need to have a mechanical side of it, but everyone still thinks we're like sort of scum of the earth, really. I think they look at us like we're the worst thing is like when you go to the people come to these places where we work, they always congratulate the service manager or the service advisor, but they never ever think about the guy in the workshop or the woman in the workshop who are actually doing the hard work in saving the money by diagnosing the job right first time. So I wish people would think we're a lot more than just greasy oil people. We're quite switched on and we need to know a lot. So that's the biggest myth I want to debunk, really.
Well, I think this podcast has gone a long way to help debug that myth with some of the stuff you've talked about, to be fair. If you were in my shoes, what question would you have asked yourself that I didn't?
It's a good one, that, actually. How can I think about that?
Is there anything I've not?
Why on earth did you choose? Why did you choose to be a mechanic and not something else? That's the biggest question. I ask myself that every morning when I wake up, really, because when I started as a young lad, I was about 14. My mum and dad wanted me to go into medicine, wanted me to be a doctor. I mean, at 15 at work experience, I was a foot doctor, podiatrist, a chiropodist, trying to be interested in the old ladies' feet. So, and I was all set for a career in medicine. And in fact, the first year in college, I did science and I sort of walked away from it, really. And it was a pure accident I ended up in this industry. It was my friend who went to Pagefield and said, come and do mechanics with us, you'll love it. Well, that's the history. I did it and I was quite good at it. I found I had a good aptitude. I come top of the class and then the rest is history, as they say. But that's the question I wish you'd have asked me, because that's the answer I would have given. I should have been a doctor.
You should have been a doctor. Well, I think you're a doctor of cars in some regards, and maybe, viewed as that to a degree. You're doing what a lot of doctors do with bodies, but you're doing it with vehicles. Can you give us a favorite driving track? We're going to compile a Spotify playlist for this podcast, and it's slowly growing. But what would you put if you're driving?
Oh God, I'm such a weirdo. I've got that many different musical choices. I'd have to work out what day I feel, how I feel. Funnily enough, I like it. I like the old classics, like for example, the Lost Boys soundtrack. The Lost Boys, with the In Excess and all them type of bands on there. I love all that type of stuff from 80s and that and early 90s. But I don't have a particular track. I like the Stone Roses. I like Cast, but I could also listen to Wigan Pier Bounce. So that's my musical choice. It's so weird and strange. I could have some bounce music and dance music and then some rock. So, but let's say Wigan Pier Bounce. Let's if you want that on your soundtrack for that. On your playlist, that'll be a laugh.
Right, we'll get that on there. Don't worry.
That'd be interesting.
Where can people find you online? Obviously, we've mentioned LinkedIn, but are you elsewhere online that we don't know about that people can find you?
No, not at the moment. But I've been speaking to the guy who owns the company I work for, and I will be definitely doing these YouTube videos. I just need to work out some sort of a system where we can put content on Schmeeben's website and then on mine as well. And I will build a website, but for now it's basically just LinkedIn. Yeah. But I'm hoping to get that, expand that really, to be honest. But if people need to get hold of me, they can just send me a message on LinkedIn and easily findable there.
We'll link your profile beneath this.
Brilliant, yeah.
Okay then, Ben. Well, thank you very much for joining us.
Pleasure.
On this 8th episode of the Vehicle Network podcast. I'm
sure
a lot out of that. Certainly I have, and it's been a pleasure speaking to you.
And it's been a pleasure being here.
Thank you very much again, and we'll wrap up at this juncture.